Hope you have been having a good morning so far. I'm going to be speaking on core data migrations and can we do better? For anyone who has actually worked with core data, you probably know the answer to the second half of the question. And hopefully I'll have enough time today to actually go over that half. If we run out of time, I've got office hours and I'm going to be around for the rest of the conference. So feel free to ping me and look me up. I'm Priya Rajagopal and that's my Twitter handle. So core data. We'll talk a little bit of, I'll give a little bit of an introduction on the core data stack because the components of the stack are relevant to the rest of the talk. So you've got the persistent store. That's like your SQL Lite. That's where your data is stored. You could have one or more persistent stores. Associated with the persistent store, you've got your object store. You've got your schema definition for your database. That's the managed object model. Your application will have one schema definition. A persistent store is actually created or associated with a particular version of the managed object model. Your application layer interfaces or interacts using the managed object context. You can have one or more object contexts. So for instance, you have one for the UI layer, and then there's one for on the background thread. And your application doesn't deal with the persistent store directly. It deals with managed objects, which are native representations of the entities. So in your managed object model, you describe their entities, attributes, relationship between entities, and so on. In your object context, basically handles the life cycle of your managed objects, fetching of the objects, faulting, creation, and so on. The component that ties this all together is the persistent store coordinator. You've got one persistent store coordinator. You initialize that with the model. It loads during core data stack initialization. It loads the persistent store using the managed object model. Now, in iOS 10, the core data stack still remains the same, except that from the perspective of the developer, you just need to deal with the persistent container. You initialize it with a store, and it takes care of the rest. It identifies the model that's appropriate for the particular store. It initializes it and initializes the managed objects for you. So I'm going to go a little bit on what a managed object model is. That's your database schema. You have an editor. This is where you describe your entities, attributes, relationships. The key thing over here is it's all versioned. So anytime you make a change to your managed object model, you're going to change the version that's associated with the model. But then we all know your app evolves over time. Schema changes are inevitable. And for anyone who has done any bit of core data, you've probably seen this exception. So what this exception, and when you get this exception, your app basically crashes. And so what this exception means is that, as I mentioned, during core data stack initialization, your persistent store is initialized or created or associated with a particular version of the core data model. Now, if that data model changes, and your persistent store, the data that is stored, is no longer compatible with the data model, then you're going to end up with the dreaded exception. So how do you deal with that? Of course, you can ask your users to just delete the app and reinstall. So what happens if you, well, they're going to lose their data, but basically when you reinstall the app, the core data reinitializes. You get a brand new persistent store initialized with the latest version of the core data model, and everything is hunky-dory? Not really. So welcome to migrations. So what is core data migrations? So as I mentioned, a couple of slides, you've got a source data store. So every store is associated with a corresponding data model. So let's just suppose you have a particular version of a data model, let's call it source, and you have a newer version of the data model called target. And you want to migrate your data from the source to the destination. So you want to migrate it from the source data store to a target data store that's associated with the target data model. So how do you do that? Core data requires a mapping model. The mapping model essentially defines the mapping between the source and the target data model. Now, associated with a mapping model is a migration policy. So a migration policy basically defines how data is migrated from the source to the destination data store in such a way that the new data is now compatible with the new data model. Don't blink, because I spent a lot of time doing this nifty animation, which lasts all of like 1 second. But you got your data migration policy, and there you go. So thank you. So you get the new instances. You don't move. Just to be clear, you're not moving the instances from the source data store to the destination. You recreate those instances and recreate the relationships between the new entities in the target data store. So let's talk about the kinds of migrations and how it's supported in core data. We'll use some examples to illustrate this. So this is a very simple example. You have a source model, and you want to get to this target model. And the difference is you're just renaming a particular attribute, web link, to website. A simple case. And this can be handled using lightweight migrations. So what lightweight migrations are essentially are automatic migrations. So core data basically can handle a subset of changes to the data model automatically. You don't really need to do anything. Well, you have to do a few changes, but other than that, core data takes care of it. It's extremely fast. It infers the mapping model, and it also determines the migration policy. It does that for you. So here's like a laundry list. It's OK if you don't get a chance to read it. It's on, you go to Apple's developer website. It lists the set of changes that are automatically migrated for you. So in order to do that, all you have to tell the core data stack during initialization is set these two properties to true and say, OK, automatically infer the mapping model for me. And once you've inferred the mapping model, do the migration automatically. And you can take a little bit of help from the editor. The particular example that I mentioned, if you wanted to rename website, you want to rename web link to website, you can do that. You can just say that you're renaming this attribute of web link to website. This is the older version of that, which was defined as web link in the older version of the model. And that's it. So pretty simple, but then you're unlikely going to have to just change names and so on. You're probably going to do a little more complex stuff. So here's another case. In this particular example, you have an attribute established date. It's of date format in the source model. And you want to change it to a string. You want to call it estimated year or established year, and you want it to change the type. Data type changes of attributes are not handled automatically through lightweight migrations. So you've got to do a little more work here, and that's where you define a custom migration policy. So you still let core data do the migration, but you have to give it two things, the mapping model and the migration policy. So to define the migration policy, you create a subclass of NS entity migration policy. In the example that I just showed, you're transforming an attribute from date type to a string. So I can actually define a transformation method. It's pretty straightforward over here. So you've got the policy. You've got a single transform method. And now I have to define a mapping. Just hold on to that thought. You've got a custom migration policy that you've defined. Now we'll see how we link it to the mapping. You have to create a custom mapping, very easy in Xcode. Select a mapping model template. Select the source data model, the target data model. It creates a mapping model for you. And once a custom mapping model is created, you have to now associate it with the migration policy that you define. So this is where you specify that for this particular entity, the migration policy is the university data migration policy. And if you look at the attribute mappings, this is where you specify the transformation that you need to apply to a particular attribute. So the transformation method that I had, transform estimated date to estimated year, you send in the source estimated date, that is the parameter, and it is defined on $entity policy, which in this case is university data migration policy. Let's take a little more complicated example. You again have your source model, got your target model. Now in my source model, I have a country attribute, which actually is just the name of the country where the university exists or is located in. Now I want to move that country to a separate entity of its own called the country entity. And and in addition here, I've added a code like a 2-letter country code, but you can envision adding a whole lot of other attributes to this country entity. So instead of making country, having country as an attribute in the university model, I move it out. The other thing is I have a many-1 relationship between the university and the country entities. So there are 2 things I've done. I've created a new entity named country for every university entity. And I have to make sure that there is just one country entity for a given country name, right? I mean, if you have USA, you don't want to have multiple entities named USA or Australia or whatever. So same thing, you have to define 2 things. You do your custom migration policy and your mapping model. The migration policy gets to be a little more complicated now. It's going to expand into 3 slides, so that's where you see the 1 of 3. Now, in the earlier case, remember that I just created a transformation function. Here, you're not just transforming an attribute, but you're actually migrating, setting a migration policy for the entire entity. And for that, you override this particular method, create destination instances, which is defined as part of the NS entity migration policy class. So for every entity that is defined, which is defined in the source, you create a corresponding destination instance. And that's what is happening in the code that is highlighted in orange here. So what we have done so far is I take an entity instance of an instance of a university, and I create that in the destination. The next thing I need to do is take the country name that was part of the university, and now I have to create a country entity. So I do a little bit of bookkeeping here. This slide is not that interesting. The next slide is where the actual work happens. But in this slide, what I'm doing is if there is a country entity for this specified country name, I just link it to the university. So I say destination instance, that is link university entity to the country. And this is where I actually create the country entity. So I have the country name. I insert a new object. So I create a new entity named country with a specified country name. I link the university object with the corresponding country object. And I do a little bit of bookkeeping because I don't want to create multiple instances of the same country entity. So if I've got one for US, I just need that one. And for tracking that, I use the user info dictionary, which exists as part of the NS Migration Manager object. So this is where I track, and that's what you probably, if you remember the previous slide, that's what you actually saw in the previous slide, where I'm referencing the user info, and if that entity exists, I link it. So let's just, and the last thing I do is I tell the manager, associate this source entity with this destination entity. So under the hood, core data creates an association table between the source and the destination entity and does the migration. The same thing as before, you have to still create your mapping, and you specify that this is the policy that you need to apply for doing this mapping. There is no attribute mapping in this particular example, but if I were actually transforming even the type, you would probably specify some in the attribute mappings as well. So everything I described so far is where core data handles the migration for you. You still need to you still need to provide a mapping model, and you have to describe the migration policy. But core data stack during initialization identifies, well, do we need a migration? Is the source, is the store that exists right now compatible with the latest version of the data model? If it is not, it determines that, OK, I need to do a migration. Once it identifies that it needs to do a migration, it automatically determines, based on the source and the target, what's the mapping model to use. And once it identifies the mapping model, it applies the migration policy. You still need to define all that stuff, but it does some of this stuff for you. But if you want full control over the migration process, you can go manual. And to do that, you just told core data, don't bother with migration. The app will take care of it. So you say, don't infer the mapping model, that is for lightweight migrations, and don't do the migrations automatically. You would still be responsible for creating the migration policy and the mapping models. That doesn't change. It's the same as what I discussed in the previous slides. But what you have to do is do all the hard work that core data does for you. You first need to determine if you need to migrate your current data store to the latest version of the data model. So this is what you do. You identify your current source store, identify the latest version of the data model, and you see if it is compatible. If it is not compatible, you know you have to do a migration. Then you would have to actually handle the migration of the stores progressively, because you really don't have control over when your users are going to update their apps. So you could actually have apps in the wild with different versions of supporting different versions of the data store. So you could have version 1, 2, 3, and you release an app with version 4. You need to have a path to migrate from 1 to 2, 2 to 3, 3 to 4, and so on. So that's progressive migration. And to do that, you need to identify what's the version of the model that's compatible with the existing store. It could be version 1, 2, or 3 in the example that I just stated. And then you progressively migrate from 1 to 2, 2 to 3, and so on. This is a helper function. Basically, what it does is identifies the version of the data model that's compatible with the existing store. You use the same, actually, criteria for determining if you need migration in the first place. Then finally, now that you've identified, OK, I need to do a migration, I know what the source store is, I can do the migration. I say, OK, migrate the store. I have my mapping model that maps from this particular version of the source model to this particular version of the destination model. And now I can call the Migrate Store on the NS Migration Manager. And this is, of course, finding the mapping model that corresponds to your existing version of the source. So it's a lot more work. But sometimes if you've got mapping models that don't exist in the main bundle, you probably want to do a manual. But it's a lot more tedious. If you're sitting, you sat through the first half of my talk. Well, I've got like 6 more minutes. But I'm going to assume that you're still interested on, can we do better? Can we get rid of migrations? And we can if you go NoSQL. So if you do NoSQL and use that as an option for persisting data, there's no schema, and which means you deal with unstructured or semi-structured data. And if that works for your application, you never have to deal with data migration. So you can release new versions of your app, and you never have to worry about trying to define a mapping policy and so on. And bear in mind that whatever I showed you so far is for the simplest case, one entity. I mean, you're never going to really have a database with one entity. You're going to have something far more complicated. So try defining migration policies for apps that support like 10, 15 entities and with complex relationships between them. So very briefly, NoSQL means non-relational. In a relational RDBMS, you got like tables, right? In SQLite, you got tables with rows and columns and relationships, foreign key relationships between the tables. In NoSQL, it means it's non-relational. There are several flavors of NoSQL. These are the main ones that I've highlighted. If anyone is interested in knowing more about each of these flavors, just meet me outside the conference room, and I'll be happy to discuss. But I'd like to talk about document store. Document store is where data is actually stored as JSON or XML or any binary encoded format. Here are some examples. You've got Mongo, got Couchbase, Dynamo from Amazon. Document, I think, is now Cosmos. That's from Microsoft. So you really don't have to deal with any schema. Data is stored as JSON. You consume, and if you're using web services today, they're probably serving you data in JSON. You've got JSON serializer with Swift for codables. Things are a lot simpler to handle JSON. So you can just store it in Couchbase or Mongo as, well, Mongo won't work because it's not an embedded store, but in general, NoSQL, you can just store data as JSON. So this is a comparison, but for the purposes of this talk, the key thing is structure evolution. So if your data model changes, if you're dealing with just a JSON-style document model, you don't have to deal with migrations. Now, that said, I want to also highlight that it's not a silver bullet. It's not like a one-size-fits-all. It's possible that your application needs the kind of structure that core data or any SQLite requires, right? So if your application, for example, stores logs or user profiles or chat messages, things which are more unstructured, or social networking apps and as such, it might be a good option to use NoSQL, but it's not like you just throw away core data and go wild and have no structure. In fact, you could have both of them coexist. You could have core data for a certain subset of your data, and then you can have store data which is very dynamic, likely to change very often in JSON. So they can coexist as well. So it's very easy. I think I mentioned it's easy to map from JSON to your native objects. So in NoSQL, if you consider the same example over here, if I had to add a new attribute, there's no schema. I just add it to the JSON, right? I mean, and your application should just take care of it. Now, if I have to change the type, so I have the established date property, and it is of type double. And I want to change it to string. Do that. You just create a new document and say established year. Of course, it's not magic. I mean, you still need to do, the onus is on the application side to determine, OK, if established date is present, then display it or handle it a particular way. If established year is present in the document, handle it a particular way. So the key is, in NoSQL, the database itself doesn't enforce a schema that this has to happen. The burden is shifted to the application to ensure that it is parsing the data the right way. So I've got time, 1 minute, and I'm going to just give you a sneak peek. And if you're sick and tired of doing core data migrations or even SQLite migrations, or if you have an application which doesn't really need the structure that a well-defined schema dictates, then there's Couchbase Lite. It is open source. It's a JSON document store available for all your platforms. And you have a full text search. So it's not a wrapper on SQLite. Don't get misled by the SQLite engine that you see there. The SQLite is just used as a data store. So the data is still stored as a JSON blob in SQLite. It's not like your JSON gets transformed into SQLite tables. So that doesn't really happen. So this is like the architecture. I want to have time to go over that here. But if you're interested more on Couchbase Lite and how it can be used in your application, be happy to show some code and walk through some examples. And these are more resources. The office hours or the hours, I think we have, it's in your app somewhere. It tells you the slot where I'll be available if you want to know more. And I just made it on time, so I'm happy. Thank you.